Hello, in this video let us use the order of operations, PEMDAS, to solve a quadratic equation. Usually when we solve a quadratic equation we would use quadratic formula, but in this case we will end up with a simplified version of a quadratic function, and so we could use the PEMDAS instead of a quadratic formula. So let's use this example to practice how to use PEMDAS, that is the order of operations, to solve any equation or inequality. So the process involves two steps. The first step is we begin at the top and we follow each step, and we perform each step only if it is always true. So if whatever is inside the parentheses can be simplified, we do that operation. If it cannot be, then we skip forward. And we go all the way until we complete all the operations. Once we simplify everything, there will be nothing else to simplify, so we will be looking at the simplest version of our question. At that point, we have to undo all of the remaining operations, and this is where the second step comes in. So the second step, we begin at the bottom of PEMDAS and we work our way up and undo all of the operations using their inverses. So for the addition, the inverse is minus. For multiplication, the inverse is division. For the exponents, the inverses are either logarithmic or the roots, and so on. Once we clean everything out, there will be nothing in front of the parentheses, so the parentheses will be redundant and they will simply drop off, and we will be able to finish our question. So that's a general principle of how to solve any equation in algebra, trigonometry, and calculus. So let's use this template to solve one example. So here is an example. We have 5x squared minus 4 times x squared plus 2 equals to 1. So following the order of operations, we'll look inside the parentheses, and if it's true, we will simplify it, and if it's not, we will move on. Inside the parentheses, we have x squared plus 2, and since we don't know what x is, we cannot do anything here. So the parentheses are finished, we're done. The next step is exponents. So the parentheses are complete. The exponents are also complete because there is nothing we can do to x squared because we don't know what x is, so we cannot square it either. The next is multiplication and division. There is a multiplication between negative 4 and these parentheses. So let's go ahead and multiply the negative 4 times both x squared and 2. So if we do that, we will have negative 4 times x squared makes negative 4x squared. Negative 4 times 2 makes negative 8 equals to 1. So that completes our multiplication. There is no division. Then we do addition and subtraction. So if it's always true, we perform the operation. 5x squared minus 4x squared. Although it's not an addition, it's subtraction. We can do them in any order. There is no addition anyway, so we can check this off. So subtraction, 5x squared minus 4x squared is always going to be 1x squared. Minus 8 is 1. So at that point, we have completed our first step. We have simplified everything, and we have ended up with an expression x squared minus 8 is equal to 1, which is still a quadratic. One of the ways to solve it is to undo all of the remaining operations. So starting at the bottom, we undo the minus first. To undo the minus, we use the inverse operation for the minus, which is a plus. So we're adding 8 to both sides. So adding 8 to both sides, we have x to the 2 equals to 9. Now to undo the square, we use the square root. So we take a square root of both sides, and we have x equals plus minus 3. There is two solutions. X is 3 and x is negative 3. Because when we have the question x squared is 9 asking us what number squared makes 9, and there are two choices. 3 squared makes 9, negative 3 also makes 9 when you square it. So we have to include both choices. Both will be the solution to our equation. So that's our final answer. Now let's use the calculator to see if we can confirm that these results actually make sense. So with the calculator, we will make a sketch. Of the left side is going to be one equation, the right side is going to be the second equation. We will look where the two equations are equal to each other, and we will look for where the two graphs cross. That's where the two equations are equal to each other. So here is the calculator. Let's put this up. And y equals, and let's type in the first equation. So here I'm covering it up. Okay, well here we can see it a little bit. So let's type in 5x to the 2 minus 4 times x to the 2 plus 2, and then on the other side equals to 1 graph. So here's the picture. This is the quadratic, that's the left side. Then there is equal to 1, and we have two places where the graphs are equal to each other. That's where they cross, these two places. Let's find them with a calculator. Excuse me. So we'll go to calculate, second calculate, and we'll look for the intersect. So intersect. Now the blinky has to be, it will find us the intersection that is the closest to this cursor. So let's find the left side first. Let's move the blinker to the left side, a little closer to the left side. When we hit enter, it marks the first curve. Hit enter to mark the second curve. Guess, hit enter one more time. The answer is -3. So the left side of our graph shows -3 is the correct solution. Now let's look for the right side and see if that comes out to be 3. So once again, second calculate, we go to the intersect, and we now scoot over closer to the right side so we can find that intersection instead. So that's close enough. Enter marks the spot, enter marks the second curve, enter is the guess. Once again, the answer is 3. So we have found that the right intersection is 3. So this picture confirms that we have found the correct two solutions. And that's how to use the calculator to double check our work on the test. Now, as we work through the different courses, we will see this order of operations, or PEMDAS, play out in algebra, trigonometry, and in calculus. So here is a quick summary. In the algebra, we have functions, we have inverse functions, or operations. So the plus and minus, these are inverses. Plus will cancel the minus, minus will cancel the plus. Multiplication and division, they will cancel each other off. Square and square root will cancel each other off. We have just done this operation. When we have an even root, we have plus minus in front. When we have odd root, we do not need plus minus. Exponential and logarithmic functions will also cancel each other out. So these are the main functions we see in algebra, and that's how the PEMDAS helps us to solve the equations that have these components in them. When we get to trigonometry, we see 6 trigonometric functions. Here they are: sine, cosine, tangent, cosecant, secant, cotangent. Each one of them comes with its own inverse, which is abbreviated with the power -1. So the sine is undone with sine inverse of x. The cosine is undone with cosine inverse of x, and so on. Each one of these functions is being undone by its inverse. Then we get to calculus. Calculus begins with the idea of limit. On the idea of a limit, there are two main ideas that are developed: the idea of a derivative and the idea of integral. Integral is also known as antiderivative, which is a hint. It undoes the derivative, meaning it's an inverse function for the derivative. So once again, we have two different functions or operations that undo each other. When we have derivatives, we can undo them using integrals. When we have integrals, we can undo them using derivatives. And these are the principles that we will see in algebra, trigonometry, and calculus. And this is why PEMDAS is so important, because once we have a good understanding of how this principle works in all these courses, it will make each one of those courses a lot easier to deal with and a lot less to memorize. So this is it for our example of PEMDAS. And if you have any questions on anything, please let me know. Thank you for your time. Take care.